Okay, so today's topic is basically the minimal polynomial. So what is the significance of the minimal polynomial and what is the purpose of this minimal polynomial? So we will discuss this topic side by side considering this PDF book and also one PDF which I have downloaded, and I will also upload it to your classroom. And the first thing first is that the same thing is written here, that the cyclic code is a property of the code vector multiplying the message polynomial, that is mx, and the generator polynomial, that is gx. That means, which I have told you that how to generate the code vector in case of cyclic code. It's basically the multiplication of the message polynomials and the generator polynomials. So here you can follow that being a polynomial, gx has its roots that are in the number equal to its degree. Okay, so gx is also expressed in terms of polynomial or in terms of x polynomial equation, like 1 plus x cubed. So in case of that equation, the degree is 3 because x cubed is the highest term, okay, with the highest degree. So, and the roots, the number of the roots is also 3. Okay, so this is basically written here. And also a generator polynomial with a coefficient over gf2 need not have all of its roots belonging to this field, as some of the roots can be elements of the extended field, which is gf2 to the power m. Okay, gf2 to the power m, and this concept is described and clarified in appendix B. So what is written in appendix B? So let's go to appendix B. You will also follow appendix B when you study from this PDF book. Okay, so just go to the appendix B, what is written. Let's see. Okay, so here is the appendix B, and the page number is, you can follow from the content, that 341. So this is the appendix B, and appendix B is all about Galois field GFQ. Okay, so this previous notes is not required because this is already given to you in your previous lecture or previous notes. So you have to follow from, this is basically the addition and multiplication, which I've already told you how to do that, and you have to follow from polynomials about the binary field from this. Okay, so here you can see that we have considered gf2 and gf2 to the power m. So as I've told you that in case of gf2 to the power m, this is a non-prime elements, the set of non-prime elements. So we will introduce irreducible polynomial equations, and for that case, n equals to 1. So there are 2 to the power n polynomials of degree n. So I've already seen you the table of the Galois field from my handwritten note, that when n equals to 1, so this is the possible polynomials, that is x to the power 1 and x to the power 1 plus 1. So this is the in the decreasing order. You can see that it is in the decreasing order. So what is the possible polynomials considering degree n equals to 1? That means x to the power 1 and x to the power 1 plus 1. Okay. When n equals to 2, that means the degree is 2. Then the possible polynomial x square plus 1, x square plus x square plus x plus 1. Okay, so these are the possible polynomials considering the degree of 2, right? Okay, and I've also seen that when the degree is 3, so the possible polynomials, okay, in my handwritten note. Okay, so the thing is that you have to consider this definition b.1 and this definition b.2 very carefully. Okay, the definition b.2 is basically needed for our topic of minimal polynomial. So what is that? It is written here that the polynomial px defined over gf2 of degree m, okay, is said to be irreducible. A polynomial equation is said irreducible. That means an equation when this is not reducible. That means we cannot find any factor, or you can say irreducible means you cannot factorize that polynomial equation. Okay. And what is the condition to be irreducible? That if px, that means this polynomial, has no factor polynomials of degree which is higher than 0 and lower than m. Okay, a polynomial px defined over gf2 of degree m is said to be irreducible or non-factorizable if px, that means that polynomial equation, has no factor polynomials of degree which is higher than 0 and lower than the m. And m is the, you can say, the mother polynomial equation, or you can say the main polynomial equation which has a degree of m. And if that polynomial equation, that mother or that uh, main polynomial equation has no factor polynomial equation, or has no factor, because that factor will be also a polynomial equation. And if that polynomial equation, that factor polynomial equation, have a degree which is not higher than 0 and less than m. Okay, like you can take example like 1 plus x plus x squared. So if this is a mother polynomial equation or the main polynomial equation, so you can see that since neither x nor x plus 1 are its factor, that means its factor polynomial is x and x plus 1. It could be, but it is not. Okay, so since neither x nor x plus 1 are its factor, okay, so a polynomial of degree 2 is irreducible. That means this is, you know, that this is the polynomial equation of degree 2 is irreducible if it has no factor polynomials of degree 1. Then only this polynomial equation will be called the irreducible polynomial equation. Okay, so any polynomial equation of degree m, if it has no factor polynomial equation of degree which is higher than 0 and less than m, is called the irreducible. So in case of 1 plus x squared, the degree of polynomial equation is m, but the factors, there is no factors which have the degree which is less than 2 or greater than 0. That's why 1 plus x squared is an irreducible polynomial. That means the possible factor x and x plus 1 is not there. Okay, or you can say the property of the irreducible polynomial over the binary field gf2, the degree m, is that they are the factors of the polynomial x to the power 2 to the power m minus 1 plus 1. That means, for example, the polynomial 1 plus x cubed, the highest degree is 3, m value is 3, x cubed, so the highest value is 3, so m value is 3. Okay, is the factor of x to the power 2 to the power m, the m value is 3, so 2 to the power 3 minus 1, so it is the factor. That means this is the factor polynomial of x to the power 7 plus 1. So when it will be given that the degree is 3, the degree is given and the degree is 3, so you can say that this polynomial equation is a factor of x to the power 2 to the power m